Okay, today we're going to work on a kuta software continuity worksheet. It says find the intervals on which each function is continuous. So when we're looking at finding limits, we're looking for continuously smooth curves, no breaks or no openings. So on these curves, what we're going to do is on each of the graphs is we're going to tell what the interval where it is continuous this time instead of discontinuous. So we know by looking at this first one, x squared plus 2x plus 1, we know it's going to be a parabola. So that parabola is going to open up because it's got a positive 1 in the front, right? We also know that this one down here is going to be a line in the form, this is like saying negative 1/2 x plus 0. So we would go down 1 and put a dot, start at 0, put a dot, and then go down 1 and to the right 2 to get our slope. So it says that it's less than 1, it's the parabola. If it's greater than or equal to 1, then it's going to be the line. Now notice the less than is the open circle, and the greater than or equal to is the filled in dot. So in this case, we can see that it starts out coming down this way being nice and smooth and everything, and then all of a sudden it stops because it stops up here, right? And then it starts again down here, so it goes on the line. So what part then do we show then as continuous? Well, at 1, it stops being continuous. So the way we're going to write our answer is we're going to say the interval on which it's continuous is going to be parentheses negative infinity to 1 parentheses. Now the reason why we did parentheses because it was an open circle, right? So negative infinity to 1 parentheses, and then union that with this one down here, which would be 1 brackets to infinity, positive infinity. And the reason why it's filled in, that's why we have brackets. So this would be the intervals on which the function is continuous. Okay, let's look at number 2. Number 2 is a little bit different. It still is, and I should have asked you this, what kind of a function are these things that we've done so far? These are called piecewise functions. Okay, so it breaks up the domain into pieces. That's why they call it piecewise. So this one says that it's 1 when x is not 5. Okay, so see how this is a 1 right here all the way across? Except at 5. So at 5, it's equal to 3. So that's this dot up here at 3. So it starts out smooth and continuous, 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 and oh, there it stops right there, and then it keeps on going continuous and continuous and continuous. So where does it stop being continuous? Again at 5. This is the 5, right? So our parentheses is going to be parentheses negative infinity to 5, parentheses, because it's an open circle, union with parentheses 5 to infinity. Again, parentheses because it's an open circle. Okay, so we're okay with those two. So we're going to go to the next two. Now these we have to draw our own graphs. So we're going to see what we have with these graphs. So the first one says find the intervals on which each function is continuous. You may use provided graph to sketch your function. So we're going to sketch our function. So the first thing we're going to do is we're going to figure out what kind of line this is. So we have y equals 2x minus 10. So we know that that's going to be y equals mx plus b. So my slope is going to be 2 over 1, and my b is going to be negative 10. So you agree with that? So for less than 2, it's going to be this line. For greater than 2, it's going to be 0. Okay? So less than 2, it's going to be this line. So we're going to graph it first. So we go down to 10. We put our dot negative 10. And then we count our rise over run. So there's rise over run, another rise over run. So I went up 2 and over 1. That's what this 2 over 1 is, right? Now, why did I stop here? Well, I stopped here because that's where the other line takes over. So this is going to be an open circle because this one right here started from going off this direction, right? So this is going to be an open circle because we have the less than 2 is open circle. Then it says starting at 2, so filled in dot now, it's going to be to the right on the x-axis because that would be where y equals 0 is going to be all along the x-axis. All right, so what is our interval now going to be? Well, you can see that the place where it stops being continuous is at 2. So we're going to write parentheses, negative infinity to 2, again parentheses because it's an open circle, union with the one up here on the top, which is going to be what? Brackets 2 to infinity. The brackets is because, again, it's filled in dot. All right, number 4. Again, we're looking for where it's continuous, so we have to factor this numerator first. So we're going to factor, and we get x squared is going to go in for x and x, and then 2 and 1. Since this is a negative 1, then we know the larger number has to be negative, and this one has to be positive. So we divide, and we get x plus 1. Okay, so you agree with that? Now, we know that we can take the x plus 1 and cancel it out. And so what does that form for us when we do that, cancel the x plus 1 out? That gives us a whole that we have to look at later. So this now becomes f of x equals x minus 2, or y equals x minus 2, because f of x and y are the same. We use them in the same way. And our whole then is going to be at x is going to equal, is going to be 0, so x is equal to a negative 1. So at negative 1 is where we're going to get our whole for x. But first we have to draw our line. So how do we draw our line? This is y equals mx plus b, so my m is going to be 1 over 1. So I'm going to go down 2, and then I'm going to go up 1 and over 1, down 1 and over 1, so I can get myself a line. So at negative 1, though, down 1 and over 1, let's do one more. At negative 1, I know that I'm going to have an open circle. So this is going to be my open circle, and then the rest of them is going to go off like this. Down 1 over 1, down 1 over 1, until we get ourselves a line. Okay, so this is an arrow. So again, we can see where our discontinuity is at this x equals a negative 1, because that's where our whole is. The whole comes from taking x plus 1 out of the top and the bottom at the same time. So that's where this x equals negative 1 comes from. So my area of continuous is negative infinity to negative 1, parentheses, union, parentheses, negative 1 to infinity. Now this time we don't have a brackets because there's not a filled in circle. There's only open circle in this one. Okay, so we'll go to number 5. Okay, now on number 5, there's nothing that we can factor. It says find the intervals on which it's continuous again. But we can have something to look at here. We got a 2x plus 4 is in the denominator. So what do we know about a rational function? That we can't have 2x plus 4 equaling 0 in the denominator. So when I subtract 4, we get 2x cannot be a negative 4. Divide by 2. I get x cannot be a negative 2. Now, that x cannot be a negative 2 is a what? That's an asymptote, right? A vertical asymptote. So we'll have to look and see what that means later when we look at the situation, but in this case where our interval then is going to be, where it can't have is the -2. So we're going to go from negative infinity to -2, parentheses, union from -2 to infinity. So it's not a hole this time, but it's a asymptote that's going to cut across our graph. Okay, we're not going to take time to do all these, but we're going to do a couple more. So this next one underneath, number 7, we're going to look at number 7 and factor the top, the numerator, and bring down the x plus 3 in the denominator. So I get x and x. Factors of 12 that subtract to be 1 is 4 and 3. We know that the 4 has to be the negative one because it's the number that matches here. So subtract and take the sign of the larger gives us that in here. So when I cancel this out, this is going to give me a what again? It's going to give me a whole. So my x plus 3 cannot be 0. It's going to give me x as a whole at -3. So we'll come back and get that in a second. So our place where it stops being continuous now is the -3. So we're going to have the interval from -infinity to -3, union from -3 to infinity. This one is done the same way as number 7, so we're not going to take time to do that one. Number 9, looks like 9 is almost exactly the same thing as number 5. You have on this one you have that x cannot be 2. So it says if the function is not continuous, find the x-axis location of the, or classify each discontinuity. So this one is at x cannot be -2. And it looks like this one is divides out to be imaginary. So this one you're going to use the quadratic formula on. This one up here, you're going to, looks like cancel out x plus 1 again, so that would cause a hole. And it's called removable if you have a hole in it there. And let's see, here we have x cannot be 1. So use what we've done on the ones on the first page and the second page to see what you can do with the rest of them. If you have any questions on any of these on this particular assignment, then let me know so I can answer the specific ones now that you have the paper to look at. Okay, the next thing we're going to look at is the one that says we're brewing math on the front and has a coffee cup. Let me pull it up so you can see what I'm talking about. The one that has this picture on the front. So limits at infinity and -infinity. All right, so open up that, and you have something that looks like this. Okay, we're going to start with problem. Now, you'll notice these are not numbered in order, 1, 2, 3, 4, 5, 6, or anything like that. So what we're going to do is these letters up here with the answer, it's like those things you used to do when you're younger, where you match up the numbers with the letter that's next to the problem, and it spells out this answer to a question. So the question is, why should you always trust a glue salesman? Okay, so our process is to find out the answer so we can come down at the bottom and see what they are. So this first one, it says find these limits at infinity to find out why you should always trust a glue salesman. Match the solution at the bottom of the page with the problem number. All right, so we're going to start out first. This says that x goes to -infinity. Now, if it goes to -infinity, then what we're going to consider is first what things don't matter. Okay, this 2 is really not going to matter if you're talking about infinity. 2 is going to be so small and minute that it doesn't really matter. So the other thing we can see that's in common is that these both have an x squared. So I can take out an x squared. So let's go say this one's going to be -2x to the third over 3x squared. So if I take out an x squared out of the top and the bottom, I end up with -2 x, because I still have an x in the top, over 3. So now, if this goes to negative infinity, then that number negative infinity would multiply by the number out front, and that would make it become positive infinity. So my answer is positive infinity. So you see what I'm saying? Negative infinity, if x is going to negative infinity, negative times negative makes it be positive infinity. Okay, so we would match all the positive infinities down below with c. So positive infinity and c go together. So you see how to do it? So the next one we're going to come across, the D one. Again, if we're talking about infinity, so this one says x goes to positive infinity. So if x goes to positive infinity, the 16 and the 4 really don't matter when it comes down to infinity. That's very minute. So we have 1 over x squared. So if I'm going to infinity and this number on the bottom of the fraction gets bigger and bigger and bigger and bigger and bigger, then what is this coming to the limit to be? If the bottom, the denominator, is bigger and bigger, that makes the fraction smaller and smaller. So eventually it's going to approach and be equal to 0. So 0 is our answer, and D is the letter we match it with. So you get the idea? All right, so let's do E. This one says that x is going to negative infinity, so which thing are we going to x off? We're going to x off the minus 3, so now I have negative x over x, which the x's would cancel out and give me negative 1. So this is the limit as x goes to negative infinity of a constant, still going to be negative 1. So negative 1 matches with E. Okay, so we're going to go down to H. So what are we going to mark out on H? Okay, well, the 1's going to be marked out because it's minute compared to the rest. So I get x squared over x, but then we can cancel one of the x's out, so that gives me x over 4. And it says as x is going to negative infinity, so the numerator now is negative infinity, so that means that the whole thing will be going to negative infinity. Because the bigger that the numerator gets, the bigger the whole fraction is going to get. So that would make us come out to negative infinity. So negative infinity is matched with H. All right, what doesn't matter on this one? What is the minute part? So this negative 1 is minute, doesn't matter. So now I get negative 2x over x. So what happens to the x's? The x's cancel out, and I get negative 2. Negative 2 is matched with I, right? All right, let's see what k does. K is going to positive infinity. So our 2's really don't matter, and our 4 really doesn't matter. So inside here, though, we have to take into consideration what do we have. Both of these are inside, so I can cancel out both of the x squareds. So I'm just left with the cube root of 3. And that goes with k, right? Okay, we're going to jump down to do the one right below it because it both being in the cube roots. So in this one, we have the 3 and the 1 go away. The x's go away because they're both x squared. So now I have the cube root of 1/3. Now, we can't leave that radical with the cube root. So this would be like saying 1 over the cube root of 3. So normally we'd multiply by the same radical, but that's when we have square root. This is cube root. So now I'm going to take this and I'm going to multiply the top and the bottom by the cube root of 9. Now the reason why I use 9 is that if I take 3 times 9, that gives me the cube root of 27, which gives me 3. So then I have cube root of 9 over 3. So everybody see where the cube root of 9 comes from? Cube root of 9, 9 times 3 gives you 27. 27 is a perfect cube root for 3, and that's what we needed. So that's matched with R. Okay, the next one has a radical in the numerator and doesn't have one in the denominator, so we have to do some consideration first. So the 4 and the 2 really don't matter. So now if I take this square root of 2, the square root of 2 is going to be in the radical, but the square root of x squared is going to come out as x. And on the bottom we still have 4x, so the x's cancel, and I'm left with square root of 2 over 4, which would go with O. Okay, these aren't that bad, are they? So the next one over here, you've got the square root of the 1 and the 2 don't matter because you're talking about infinity again. So the x squared and the x are one's out of the radical and one's in the radical, so we have to do the square root first. So this gives me 2x over 4x. The x's cancel, and then 2 and 4 can reduce to 1/2. So this is going to be n. So every 1/2 is n. Okay, number S, or letter S, we've got 3x. So 3x over the 4 doesn't matter because it's so small. And then this is going to give me square root of 2 times x, because the square root of x squared is going to give you x. So the x's cancel, and I'm left with 3 over square root of 2. But we can't leave it like that because we need to rationalize the denominator. So this time now, since it is a square, then we can multiply by the square root of 2 in the numerator and the denominator. So I get 3 square roots of 2 over 2. And that goes with S. And we've got T, same kind of idea on T. You've got the 1 and the 2 cancel out, they don't matter. Square root of 3 and square root of x squared is going to give you 2x over square root of 3 times x, because the square root of x squared is going to be x. The x's cancel, so I get 2 over square root of 3. But 2 over square root of 3, to rationalize, I would multiply by square root of 3 in the top and the bottom, because again, this is square root, not cube root. So my answer is 2 square roots of 3 over 3. And that one goes with T, so this one goes with T, and this one goes with S. And then over here, the 9 goes away, the x squareds go away, and you can just see where it's going to be a 2. So that's W. And the last one, the 4 goes away, the x squareds go away, and I just am left with 3 then, right? So see, that wasn't so bad. So now we have to match all these things with these letters down below. So let's see what we got. All right, so 2 square roots of 3 over 3. Looks like that we have a negative, should have been. Let's see what we got. 2 square roots of 3 over 3. Yeah, T should have been negative because we went to negative infinity. And was there any other ones? Let me see. I don't think so. All right, so the negative 2 square roots of 3 over 3 is going to be T. So is there any other ones that's that one? Okay, it looks like a T here and a T here. Well, lots of T's. There's a T and there's a T. Okay, that looks like all the T's. Let's make sure eyes cross. All right. The next one says negative infinity, so that's an H. H. Any more negative infinities? H. All right, the next one is a negative 1. So do we have a negative 1 anywhere? Okay, an E. So you see any other negative ones? E. E. Okay, the next one's a 3, so 3s, Y. Got all the 3s. Okay, the next one is a negative 1/2. Looks like this one's the same as the T was because it's going to negative infinity. So negative 1/2 would be an N. Negative 1/2, negative 1/2. I think that's all the negative 1/2s. and then an O, or a 0, I guess it would be. So looking for a 0. Looks like it's D. D down here too. And then the next one is the square root of 2 over 4. Square root of 2 over 4 is O. See the other square root of 2 over 4 is O. Square root of 2 over 4, O. And we have 3 square roots of 2 over 2, which we said was S. Negative 2 square roots of 3 over 3 is T. Number negative 2 is I. Infinity, positive infinity this time, not negative infinity, is C. And cube root of 3 is K. So what else do we have? Any more K's? Negative 2 is I. Cube root of 9 over 3 is R. 2, positive 2 again is W. And the last one, cube root of 9 over 3 is R again. So we make some marks right there, 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 there. Okay, so what does it say? They tend to stick to their word. Haha. All right, so that takes us through that one. We're going to stop and take a little break, and then we'll come back and do the rest of them. Thank you.